Thank you, Chu Cheng, for your insights. I'm very excited to welcome our next Fireside Chat guest, Kevin Scott. Kevin is the Executive Vice President of Technology and Research and the Chief Technology Officer of Microsoft. Kevin is a prolific multi-hyphenate. He's a builder, having previously led engineering at LinkedIn through an IPO and overseen mobile ads engineering at Google. He's also an advisor to several Silicon Valley startups and an active angel investor. He's also the host of the podcast Behind the Tech, which features interviews with technology heroes who have helped create the tech industry of today. Kevin is a published author whose book, Reprogramming the American Dream, explores how AI can be realistically used to serve the interests of everyone. I could say much more, but with that, I will turn it over to Kevin. Welcome, and thank you so much for joining us today.
Thank you so much for joining us, Kevin. Really excited to be chatting.
Yeah, thanks for having me.
You know, one of the things that's always great when I talk to you is that you're able to bridge this massive divide between knowing the sort of technical details very well, while also being able to have a very clear macro picture on how that technology is affecting the world. So the first question I have for you is, what do you think are the macro trends that are going to define the future of AI over the course of the next decade?
You know, I think there are the things that we all are relatively familiar with. So AI is certainly getting more powerful over time. I think the interesting thing about the macro is that we have an interesting set of challenges that are facing us as a society where AI, I think, is an important part of the solution. So you think about things like climate change, like the thing that we just experienced, which is going through a viral pandemic. AI, I think, is and will play a huge role in helping us tackle these things. And if you think more broadly about how you provide healthcare and just sort of access to high quality medical services across the board, like that gets much more important over time, as in most of the Western world, we're about to experience a demographic inversion. So we will very shortly have far more elderly people who are retired and out of the workforce, and who have different medical needs than younger people, than we have working age folks. And so how to take care of that aging population, how to make up for the productivity that that they represent as they leave the workforce and retirement. Again, all of those things I think are going to be places where AI is critically needed. So I'm just sort of looking at a world where if we don't invest super heavily in AI and figure out how to deploy things as quickly as possible to solve some of these big societal challenges, we're gonna struggle.
It's a very interesting, macro view. Kind of looking at the other end to kind of the things that are happening on the technical ground. What are some of the exciting advancements you've seen in the field of AI that you don't think people are sort of talking enough about or excited about?
The thing that we've seen over the past couple of years in particular is these large self-supervised language models have really revolutionized how natural language processing is working. So this started with Google's BERT models and this whole notion of models that have attention, or self-attention, and this transformer architecture for deep neural networks is proving to be an extremely powerful thing, and we're already starting to see the same basic set of ideas applied to different domains. So we're quickly going from language to like visual representation models that you can pre-train and then use in a whole bunch of different applications. And so like the two properties of these models that are just fascinating is, one, because they're self-supervised, you get into this mode where you're primarily constrained by the amount of compute that you can throw at building the models. So if you have a big enough supply of data and it's like unlabeled data for the pre-training set of tasks, and you can throw lots and lots of compute, you can build bigger and bigger models, and the models are getting more powerful with that scale. So that's super exciting. And then the other exciting thing is these models, as they are getting bigger, transfer learning is actually working really well in them. So you can train one model, and then with either no additional training or some amount of fine tuning with with supervised learning, you can use them in a huge range of applications, and so you can start to think about the models themselves as platforms. So like they're reusable, you can compose them, and like I think that is just an incredibly exciting thing that. I know all of us, like probably the people attending this conference, have internalized that, but I don't think the tech industry at large has really internalized what a profound change that is.
It's a super interesting notion, this thing that you mentioned around models as platforms, because I think, historically models have always been this very fragile thing that almost, they're almost anti-platforms. They're very specific. But as the idea of models being so generalizable, so composable, so reusable that they become platforms themselves is very powerful, and there's a lot of economic implications. One thing that's related to what you just mentioned was that we're kind of in this regime, as you described, where for the state-of-the-art results or the best possible algorithms, you have to keep throwing your more and more compute at them, keep throwing more and more data at them, such that the sort of economic constraints of actually creating these very large algorithms, has gone from millions to tens of millions of dollars to train these like very, very large algorithms. Where do you think this goes long term, and what do you think the implications of that are on AI development and sort of the industry of AI?
We certainly have this really interesting crank that we are able to turn right now with these large models, where I don't think we're at the point of even diminishing marginal returns yet. So we just know that you can use more data and more compute to create bigger models that have increasing amounts of power. But it's really striking to think about the difference in the amount of energy consumed by training one of these models and the energy that a human brain consumes, which is in the tens of watts for a human brain, and like these big model training runs like consume enormous amounts of energy, and so I think that is a clear opportunity for us to be thinking about more efficient algorithms, more efficient ways to train these models. And so I just, the thing that I would say to everyone is I don't think we're at the point now where like all of AI is solved. Like every time anybody has sort of said that AI is solved, like they've, figured out the architectural approach or the technological approach to solving a set of AI problems, they've been wrong. And I think there's just enormous amounts of opportunity for innovation going forward. But it is exciting right now to to sort of think about how we can put the power of these big models into lots of hands. So while it's expensive to train a big representation model for a particular domain, what we're seeing internally is that it may actually be cheaper than what we were doing before because of these platform effects due to transfer learning. You train the model once, and then you're able to just deploy it in a whole bunch of different scenarios, where each of those scenarios before might have required a team of data scientists, accumulating a whole bunch of data, training a model, and you've got a bunch of separate models that each require their own training regime to do each one of those tasks independently. And so, we don't have conclusive data yet right now, but it could be that platform effect makes it net cheaper. And then, if that is true, then it becomes mostly a question of access. Like, how do we package these models up in a way where everybody can use them? Like, we figured out how to do it inside of Microsoft in a reasonable way. We have not figured out a great way yet how to package these things up so that we can put them in the hands safely third-party developers. And that's a thing that we're focusing an intense amount of energy on right now to try to figure out how to both empower people, but to do it in a safe and responsible way.
Yeah, one of the things that you just mentioned that I think is super interesting is kind of how the technology affects kind of the economics of what it means to build amazing products. And, like the parallel I'll draw is the incredible thing that happened with software is that while it takes an incredible amount of upfront investment to build software, the cost to reproduce software is very, very low. And that sort of change in the physics of economics, had large implications for how obviously technology and the economy has developed in the time since then. You mentioned one of them, which is that there's kind of like these platform effects of these large algorithms in terms of making it so that the marginal development cost is actually low. Are there any other like sort of changes in the physics of the economics of technology that you think are caused by AI?
There are a bunch of things that probably are going to change. You sort of alluded to it in what you just said, which is for the entire history of computing and software development, harnessing the power of a computer was about programming it, which is a trained programmer trying to come to a human understanding of how to solve a problem and then translating that human understanding into a set of step-by-step instructions for telling a computer how to go solve the problem. And so, it's not the easiest thing in the world. It's easier now than when I, started programming when I was 12, because we have figured out very cleverly how to layer abstractions, and like you just have more power now than ever. In a single line of code just does more. But like the really interesting thing that I think is happening right now is like big chunks of software development is going from programming to teaching. So, and like I think this is something that you all very, very deeply get. So you're now able to harness the power of the computer to solve problems for people by teaching it how to solve a problem, which I think is a much more accessible way of harnessing that power than programming. Like even a 2-year-old child can teach other human beings how to do something. So like teaching is part of like what we all understand how to do. And like I'm really hopeful that will be one of the things that really changes the laws of physics, as you put it, of how software development happens, that like we just have more people who are able to do a richer set of things with technology as a consequence of machine learning.
Definitely. Well, I wanted to focus in on kind of one of the things that you mentioned earlier around responsible and ethical AI. So you published this book last year called Reprogramming the American Dream, in which you talked about how your own journey from growing up in rural West Virginia to becoming a leader in technology and AI, how that shaped a lot of your beliefs. You also talked about how you believe that AI could, be a massive source of good for the general public. What are some of the ways in which you think that AI is going to positively impact people outside of the tech industry?
Let's just pick the healthcare and like how we're solving major health crises like the COVID-19 pandemic. So what we've seen is that as we partner with companies in developing therapeutics and vaccines, increasingly that development process is about harnessing like very, very powerful simulations of how molecular systems behave, and using like increasingly sophisticated data analytics like in all parts of the therapeutic and vaccine development life cycle. And one of the really exciting things to me is that we've seen it first in diagnostics, is AI as a diagnostic tool is getting really quite powerful. What I've seen over the past 12 months is AI as a way to help accelerate the development of medicines is becoming increasingly powerful. And I think if we I talk about this in the book. Like we, in the 50s and 60s, we had this like interesting set of developments in aerospace, and at one point, like we decided as a society that we were going to create the Apollo program, that we were going to build all of the technology required to send a person to the moon, and in a certain sense, that moonshot, was arbitrary. Like we didn't need to go to the moon. What we needed was to like get everyone focused on this audacious goal and to like build an entire ecosystem of technologies that would help with defense, would help with travel and transportation, and even change like our mindset of how technology plays a role in shaping society. Like the whole notion of that we're going to the moon, like we say moonshot right now to be a euphemism for an ambitious, like a really ambitious thing, and like so that effort shaped our vernacular, like how we think about the world. And like I think we have an opportunity right now with these technologies where you could pick a thing like healthcare. We could say we want to figure out how to give every person access to cheap, super high quality healthcare where they had a better life from the time they're born until the time that they pass away, and that we are going to take technologies like AI, which I think are going to be very important to providing that. But like we look at it all up and say like, we're going to do whatever it takes to use technology to make that vision a reality. So I think there's that opportunity for AI. And in a sense, you don't have to pick healthcare. Like we could pick climate change. You could pick other problems. But I think we could pick better than the moon, right? Because these things are not arbitrary. Like they are like real, tangible things that we struggle with. That if we were able to solve them, like no one would have any argument whatsoever that they would make the world a legitimately better place.
Yeah. What are that set of? You mentioned a few of them. Healthcare, climate change. What are that set of AI moonshots, so to speak, that you think that for people watching or people excited about the industry of AI that we should be focused on?
I think those are maybe the two most important ones. But like you do have another couple of ones that are sort of tangentially related. Like one of them is like trying to figure out how we can take care of an aging population, and like partially that's about healthcare, but like partially it's also about how we balance out this changing nature of like, how do you deal with the productive output of society, like at the same time that you're like, compassionately, caring for, the aging population, ensuring them that they have dignity throughout the full course of their life. There's like a whole bunch of interesting things that are not necessarily about, medicines and diagnostics that like AI I think could help with there. And then you also have, like this is related to climate change a little bit, but we have slowing population growth, which is going to result in this demographic inversion that we've talked about in most of the developed world. So for sure, in China, Japan, Korea, in Europe, and in the United States, immigration, and but that doesn't mean that we've hit peak population yet. We probably still have another like 2.5-3 billion people who are going to be added to the population, and a lot of that population growth is going to be in Southeast Asia and in Africa. And so, if you look at that, another 3 billion human beings that are coming into the world at the same time that climate change is making agriculture more difficult. Like I think we're gonna, have to look at technologies like AI to figure out like how we can optimize our agriculture so that we can feed everybody. So like that's sort of the bucket of things that I'm thinking about, and I'm sure Like we had all of the smart people in the world thinking about, like what could you do if you had 2% of your GDP to, like the United States GDP to invest in technology whose benefits accrued entirely to the good of the whole. Other interesting things would come up as well.
Yeah. No, I think what you just described in terms of AI for agriculture is super insightful and something that I actually think, not that many people are focused on, because I think that those set of macro trends are maybe not as obvious to most people. Kind of stepping back or stepping into the weeds and thinking about ethical and responsible AI, what role do you think the data sets and the algorithms play in ethical AI today and over the next few years?
I think we have an enormous amount of work to do, and I think the landscape is evolving very, very rapidly. I think we are learning a lot of things right now about biases in data sets. We're learning a ton of stuff about how to manage potential harms that come from uses of AI. Like, one of the things that we have, Microsoft, is this thing called the Office of Responsible AI, and we have a set of training and a framework to look at sensitive uses of AI, and it sort of requires people to think about the harms that can come from applications of these AI systems. I think we have an inclusivity challenge right now. So, the thing that we mentioned, that these big models are becoming more expensive to train, means that it's harder to have a huge number of researchers participating in the development and figuring out how to get that inclusive set of voices in the development of the models and the algorithms and the data handling practices. I think is super important and something that we've got to think a lot about. It's just a bunch of stuff that we're going to have to do. I mean, we've done some really interesting work on explainable AI, you sort of imagine AI is going to be so useful in so many different contexts, and in some contexts, you're always going to need to have a human in the loop, where AI is sort of recommending things, and then those recommendations even are going to have to be explainable so that a human can look at the output, understand why the AI made the recommendation that it made, and then the human is going to make an informed decision. In other applications, you're going to have things that are fully autonomous, where the AI is making decisions at a superhuman rate, what you need in a self-driving car, where there are probably thousands or tens of thousands of decisions a second that are happening to keep everyone in the car and on the road safe. And so we just have to understand this full continuum of things and make sure that we have tools for every one of the applications that make sure that the way that the AI is being used in as safe and responsible a manner as humanly possible. The corollary that I will draw is, we sort of had 75 years or so from the beginning of modern software development and high level languages. Sort of happened in the 50s. And until now, to figure out how to develop a set of practices that help make sure that the software that we're writing is safe. And even then, it's there's an interesting set of theoretical results in computer science that bound what it is that you can say about a piece of code before you deploy it. And so you just never know for sure if the code that you write is going to behave exactly as you have intended. And as a consequence, we've built up all of this mechanism to help us try to find as many possible failure modes of this software as possible before we deploy it. And then after we deploy it, like we've got a set of tools for monitoring the behavior of the software, identifying failure cases, and then controlling the impact when we do find those failure cases. And we're going to have to work out a similar framework with AI. And I think the good thing is the work is starting, and like we got lots of smart people with a lot of passion working on it right now.
I think what you described is super interesting, in particular this concept of what are the methods and the mechanisms and the technologies we've built to allow us to feel confident about the code that we're releasing and feel like that we're doing that in a responsible and ethical way, and what are the parallels of that to AI, because I think that AI is not the first technology that we're going to be rolling out at large scale. I know one thing that you and the Microsoft team is really focused on is what are the platforms and technologies that are going to enable developers to be able to actually utilize the benefits of AI and make it more democratized and more accessible. What are some of the strategic initiatives that you and the Microsoft team are considering to enable this goal?
There's a bunch of stuff that we're doing, and I think you have to be fully cognizant that that people are going to come to AI in a bunch of different ways. We are plugging fairly sophisticated flavors of machine learning into tools that people use, like Power BI and Microsoft Excel, where you don't have to know much at all about machine learning to be able to solve classification or regression problems. And like in the back end, like we're using some very sophisticated AutoML tools to look at your data set and the thing that you're trying to do, the objective function that you're trying to optimize, so to speak, and helping you to not just automatically or sort of in the background set the hyperparameters for a training process, but to select the algorithm and the neural architecture for the type of machine learning that ought to be applied to the particular problem that you're solving. So you just can come to it with relatively minimal expertise. We bought this company a few years ago, and this is now released to the public, called Lobe, where we wanted to make it really, really, really easy for people to build AI tools. And I've told this story a bunch of times. The one of the designers, a founder of Lobe, lives in an off-grid house, and he's a designer by training and wanted to be able to write this little web app that would show how much water is in this cistern that they use for drinking. And so the cistern gets filled up by a well during the day that's powered by solar panels. At night when you've got no solar panels, gravity feeds the house, and so it's important to make sure you got enough water in this thing before the sun sets. And so, the way that I would solve this problem, maybe you would solve this problem, is you put a bunch of sensors in the tank, you'd get a little Raspberry Pi or Arduino and take the sensor outputs and, translate them to water levels. You'd wire it up to the internet, you'd write some code for the, this embedded control board, you write some more code to move the data to the web app, blah, 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 right? The way that he wound up solving the problem with Lobe is he put what amounted to a toilet float in the water with a piece of rope tied over it, slung over a pulley, and he had a marker, a little piece of wood that was float up and down on the side of the cistern. So when it was high, it meant that the float was low and that the water level in the tank was low. When the marker was low on the side of the tank, it meant the float was high and you had a high water level. He took a bunch of pictures of the position of the float and notated how much water was in the tank with with every one of those pictures, pointed a webcam at this thing, and then trained a model with Lobe that like translated the pictures that flowed into water levels. Like pressed a button, it publishes like a nice little JSON API, and then like he wrote some code in his web app to like build a nice little interface that showed the water levels. And like that, again, going back to this notion of teaching versus programming, like that is a very, very different but powerful way to solve problems. And so like, we're sort of thinking about all of those ways that we can give people tools to get new people thinking about these different ways to solve problems with these tools. And like we've got things all the way on the other end. Like we're building interesting infrastructure for our teams that are building these large models for OpenAI that we're partnering with. That's really just way out on the frontier of what's possible technologically. And so like I think our approach is just full spectrum. It's like, let's think about every developer and like give them what they need where they're at to use these tools.
Kevin, that was incredible. Thank you so much for joining us for Scale Transform. It's always great to hear your thoughts, not only about the long-term future of AI, but also the exciting work that's being done technically today. So thank you again. It was really great.
Well, thank you so much for having me. Like I always enjoy chatting with you, and I think you've built an incredible community, and it's great to see things evolve. So thank you for all the work that you're doing.